Hi, good morning. Today we're going to review the mean value theorem and the intermediate value theorem. The mean value theorem said that if f of x is continuous on closed interval a to b and the differentiable on the open interval a to b, then there is at least one number x equals c and then c between a and b, such that f prime is equal to f of b minus f of a over b minus a. So what it means is, if you have a graph of f of x, f of a, and f of b, and you draw a secant, and then you use the slope formula, and you find the slope f of b minus f of a over b minus a, and m equal to 3, then there will be an x value c in between a and b, and then you found out that f prime c equal to 3. And then if you draw a tangent over here, the tangent will parallel to the secant. Another example, if you have this curve, and then the secant pass to the f of a and f of b, and if the slope equal to 2.5, then in this case there will be 3 points. Okay, c1, c2, c3, and the slope f prime c1, f prime c2, f prime c2, they all equal to 2.5, and c always between a and b and never equal to the a and never equal to the b. So if one of the conditions fail, then mean value theorem does not work, is not applicable. So if f of x is not differentiable on the interval a to b, then the mean value theorem is not applicable. For example, if f of x have corner or cusp in the interval, then we cannot use the mean value theorem, corner or cusp. If f of x is not continuous on the closed interval a to b, then the mean value theorem is not applicable. If it discontinuity, automatically the mean value theorem is not applicable. Only both conditions are met, then we can use the mean value theorem for the problem. So let's take a look at question number 1. Number 1 is a question that we can use the mean value theorem. So f of x is differentiable on the interval 0 to 11. Differentiable means it's continuous and all the slope exists. So it satisfies both conditions, and it's already differentiable at the endpoint. Selected values are given. So the question asks you, are there any c between 0 and 11 such that the f prime is equal to 0? So if you read the structure over here, you can see that at primacy slope at c equal to 0 is a structure that leads you to the mean value theorem. So we need to find 2 points and calculate the slope and see the slope equal to 0. So we're going to check. So you got 0, 8, 9, 10, 11, 8. Then you found out we had 2 points that satisfy the requirement. So 3, comma 8 and 11, comma 8. And then we calculate slope a minus a over 11 minus 3, and you get 0 because a minus a equals 0. So now find the mean value theorem. So c between 3 and 11. So some people say, how come you don't use 0 to 11? 3 to 11 is a subset of this. Okay, so it's satisfied. So we finished the question using the mean value theorem. As long as you can find 2 points that calculate the slope match this number, then it's the mean value theorem. Mean value theorem always use the slope formula. Now let's take a look at question number 2. Okay, question number 2. Question number 2. Question number 2 is a question that we have done in our homework. So we have a table of values. It said the function f and g are differentiable for real numbers. The table above give values of the function in their first derivative at the select value of x. G prime 3 equal k, where k is a constant. the function h is given by this, explain why there must be a value c and c between 1 and 4 such that h prime is equal to 0. If you look at this structure over here, it basically, they ask you to find the slope as c, and you had to use the interval 1 to 4. This is a mean value theorem structure. C had to be between 1 and 4. We never equal to 1 and 4. But we had to use the endpoint because it said that you had to use fb minus f of a over b minus a. So we need to use x1 and x4 as the endpoint in the calculation. So now we had to calculate h1 and h4, see we can find the slope equal to 0. So h of x equal to f of g of x minus g of f of x. So now we're going to find h1. Okay, now I can move up so I can see the table. So now we get f of g of 1 minus g of f of 1. G of 1, okay, you get 2. F of 1, you get 3. F of 2, 5. G of 3, 5. So we get 0. You get h of 4 equal to f of g of 4 minus g of f of 4. So now g of 4, 5. F of 4, 2. F of 5, 4. G of 2 is 4. So we have h1 equals 0, h4 equals 0, so 0 minus 0, the x value, subtract x value, you get 0. Now it matched the slope equals 0, so now we can say by the mean value theorem, there is at least a c. A c is between 1 and 4. It never equal to 1 and 4, such that h prime c equal to 0. So we finished question number 2 using the mean value theorem. Let's take a look at the intermediate value theorem. The intermediate value theorem said that a function f of x is continuous on closed interval a to b. The y value m is between f of a and f of b. Then there is at least one x equals c, and c between a and b, c never equal a, never equal to b neither, such that f of c equal to m. So if we look at here, I'm going to use some real number. So f of a and f of b. F of a equals 5, f of b equals 1. And 3 is a y value between the f of a and f of b. So 3 is the m over here. So we can say that is at least one x value and give it a y value equal to 3. So now you can see it, there's at least one c comma 3. So now look at another example. F of a equals 0, f of b equals 4, and 2 is between 0 and 4. So 2 is between f of a and f of b. So now if the y value is 2, so we can say that will be at least one x value and then give you the y value equal 2. So 2 over here, we get one y value equal to 2. So C1, C2, C3. So now there will be at least 3c. And then you get f of c equal 2. So the main idea for the intermediate value theorem is that you have to find the number, okay, in between. So now let's take a look at number 3. H of x is continuous on the interval 1 to 12. Selected values are given. So we have the table. The question asks you, are there any x equals c, c's between 1 and 12, such that h of c equal to 0? H of c equal to 0. Okay, h of c equals 0, not slope. So that means we try to use the intermediate value theorem, and you have to see the number in between. Okay, so 0, is it 0 between 6 and 7? No. 0 is at 0 between 7 and -2? Yes. 0 is between 7 and -2. So now we have 2 points, okay? 3 comma 7 and 9 comma -2. Okay, then we say that 0 is between, okay, 7 and -2. So by the intermediate value theorem, that is at least one C, and C is between 3 and 9, okay, such that A to C equal to 0, because for this function to go from 7 to -2, it had to pass the 0. So now let's continue, see if we can find out the C. 0 is between -2 and 8. Yeah, correct. Is it 0 between A and 5? No. So now we have another point. 9 comma -2 and 10 comma 8. And 0 is between -2 and 8. So by the intermediate value theorem, there is at least one C, and C is between 9 and 10, okay, such that A to C equal to 0. Okay, so therefore we prove it. There are 2 times. If you want to conclude, you can make it so. In the interval, okay, HC equals 0 for at least 2 times by the intermediate value theorem. So we finished question number 3. Now let's take a look at question number 4. Question number 4. So we have this question for homework also. So we have a table for the VAT and AFT. So for the interval t between 0 and 60, must there a time t when VAT equal -5 to survive your answer? The question asks you, is that the velocity equal to -5? So the table is velocity and acceleration. So the first thing you should think is the intermediate value, because it has nothing to do with the slope. So -5 is between what? Let's say. Is -5 over here? No. -5? No. -5 not between them. -5 not between. -5 between -10 and 0. So we found it. Okay. So for C. So this time I'm going to write it slightly differently. So we say that, okay, V of 35 equal to -10 and B of 50 equals 0. -5 is between -10 and 0. Then by the intermediate value theorem, there is at least one t equal to C, and C is between 35 and 50. So such that V of t equal to -5. Now let's take a look at part D. Part D. For the interval, okay, 0 to 60, you say t never equals 0, never 60. Must there a time t when A of t equals 0? A of t equals 0. So look here. 0 is not between any of those numbers. So you cannot use the intermediate value theorem directly. But we have A of t have a very special relation. Okay? So A of t equal to V prime of t is the slope. So now let's check so you can use the mean value theorem. we want to be a of t equal to 0. Okay, we want a of t equal to 0. So now we're going to check. See, we're going to find 2 points that have a slope equal 0. 0, negative 20, 15, negative 30, okay, 25, negative 20. Alright, so no other number match. So we had v of 0 equal to negative 20, v of 25 equal to negative 20. So negative 20 minus negative 20 over 25 minus 0. The mean value use the slope formula equals 0. So now we can say that by the mean value, there is at least 1 t equals c. Okay, you can say 1c. And c is between 0 and 25. Okay, such that a of t equal to v prime of t equal to 0. So one more time. Okay, this is a subset of 0 to 60, so it works. Now we go to last question, number 5. Number 5. So we have this question for homework also. So we're going to focus on part C. So this is a table of v of t. And the question asks you, the function v of t is twice differentiable. That means the v of t is differentiable and the a of t is differentiable. On the interval 0 to 10, show that there must be a moment of time when the acceleration of the car equals to 0. We want a of t equal to 0. So this is a v of t, and you had to prove a of t equal to, you had to use the slope. Okay, a of t equal to v prime of t. We try to prove the slope equal to 0. So now, the first thing we should do is a mean value theorem, see if it works. We're trying to find two numbers that match. So let's see over here. So we got 50, 55, 60, 70, 65, 75. None of them are equal to each other. So we cannot use a mean value theorem directly because we cannot calculate slope directly to make the delta y equal to 0. Now, that means you have to think about another way. So this one is a very special one that we want to showcase. So since the mean value does not work directly, then we think about another way to do it. A of t is the slope. So let's analyze the slope. So 50, 55, 60, 70. So the number are increasing over here. So that means the slope of the v of t is positive. Okay, somewhere over here. And then from 70 to 65, it goes down. So you go from 50 to 70 and then go down to 65. Then the slope is negative somewhere over here. And then you go back to 75, then become positive again somewhere in the another interval. So the slope is changing from positive to negative, then to positive. That means the slope had to pass through 0 when you change the sign. So that is going to be our idea. So we're going to write it down. So we say that, okay, v of t is twice differentiable. Okay, so it means it's continuous and none of the slope exists. Now we're going to say on the interval, okay, 0 to 7, v of t is increasing. So v prime t is positive for some t. Okay, we don't know exactly what value. And then on the interval 7 to 8, v of t is decreasing. So v of prime t is negative for some t. And then on the interval 8 to 10, v of t is increasing. Then v prime t is positive for some t. So v prime t is changing from positive to negative in the interval 0 to 8. Right? Up, down. Then v prime t equals to 0 for at least one time by the intermediate volume. So v prime t is changing from negative to positive on the interval, okay, from 7 to 10. So v prime t equal to 0 for at least one time, okay, by the intermediate volume. Okay, so now together a of t equal to v prime t. So a of t equal to 0 for at least 2 times in the entire interval 0 to 10 by the intermediate volume. So we finished question number 5.